1. Define IP classes and identify each of them. IP classes categorize IP addresses into groups based on their range and purpose. It's like organizing neighborhoods by the number of houses they can have and the rules they follow. IP addresses is similar to house addresses, and their class is determined by the neighborhood they belong to. First octet. IP addresses are made up of 4 groups of numbers, separated by dots, 192.168.1.1. The first group of numbers, the first octet, helps identify the IP class. Class A. If the first octet starts with a number between 1 and 126, 10.x.x.x, it's Class A. Picture Class A as a huge neighborhood with many houses, hosts. Class B. If the first octet starts with a number between 128 and 191, 172.16.x.x, it's Class B. Class B is like a moderately sized neighborhood with a good number of houses. Class C. If the first octet starts with a number between 192 and 223, 192.168.1.x, it's Class C. Class C is like a smaller neighborhood with fewer houses. Class D and E. Class D, starting from 224, and Class E, starting from 240, have specific purposes and are not commonly used for regular devices on the Internet. Example. IP address, 192.168.1.1. Class, Class C. The first octet, 192, falls within the range for Class C, so it's like living in a smaller neighborhood with Class C rules. 2. Differentiate 127.0.0.1 from localhost. 127.0.0.1. Think of 127.0.0.1 as your own house address. In the world of computers, 127.0.0.1 is a special address that always refers to the device you're currently using. It's like saying, home, when you want to refer to where you are. When your computer uses this address, it's talking to itself, like leaving a note for yourself at home. Localhost. Imagine localhost as a nickname for your home. Localhost is a friendly nickname for the same thing as 127.0.0.1. It's like using a nickname to refer to your own home. When you see localhost in computer speak, it means the computer is referring to itself, and it's often used for testing or running things on your own machine. Example. Imagine you're testing a website on your own computer. When you access 127.0.0.1 or localhost in your browser, it's like saying, "Hey computer, show me that website I'm working on," and your computer responds with what's stored locally. 3. Define NIC, Network Interface Card. A NIC, or Network Interface Card, is like a passport for your computer to connect and communicate on a network, whether it's a local network at home or the vast internet. It's the card that enables your computer to speak the language of networks and interact with other devices. Physical appearance. The NIC is often a physical card or port on your computer's motherboard. It's where you plug in a network cable for wired connections or connect wirelessly to a Wi-Fi network. This connection point is like an on-ramp to the internet highway. Example. You want to watch a video on the internet. Your computer, equipped with a NIC, communicates with the internet. The NIC ensures your request for the video is properly formatted and understands the language of the internet, allowing your computer to smoothly stream the video. 4. Define data encapsulation. Data encapsulation is like putting information in a protective envelope before sending it. In the digital world, it's a process where data is wrapped in layers of headers and trailers, like an envelope, as it travels across a network. How data encapsulation works. Imagine your message is the letter, and each layer of wrapping is like an address or instruction for delivery. When you send a message, data, over a network, it's not just sent as raw information. It's encapsulated by adding headers and trailers at each layer of the network. These headers and trailers provide essential information, such as the source and destination of the data and instructions for how it should be handled. It's like adding addresses and delivery instructions to your letter's envelope. At each stop it makes on its way to the recipient. Example. You send an email to a friend. Your email message, data, is encapsulated as it travels. Each layer of encapsulation adds information about the sender, recipient, and the email's content. It's like your message getting wrapped in protective layers with important delivery details before reaching your friend's inbox. 5. Differentiate Internet, intranet, and extranet. Internet. Think of the Internet as a vast, global library. The Internet is like a massive library where you can access information, services, and connect with people worldwide. It's an open space, available to anyone with an Internet connection. You can browse websites, send emails, and share information with people from different corners of the world. Intranet. Imagine the intranet as a private office library. An intranet is like a private library accessible only to people within a specific organization. It's a network that allows employees or members of an organization to share information, collaborate on projects, and communicate internally. Extranet. Picture the extranet as a shared library between two organizations. An extranet is like a shared library that two or more organizations can access. It's a controlled and secure space where selected individuals from different organizations can share information, collaborate on projects, or communicate. Key differences. Accessibility. Internet, open to everyone. Intranet, limited to members of a specific organization. Extranet, shared between selected individuals from different organizations. Purpose. Internet, information, communication, and services on a global scale. Intranet, internal communication, collaboration, and resource sharing within an organization. Extranet, collaborative space for sharing information and resources between organizations. Security. Internet, security measures vary, open to the public. Intranet, internal security measures, restricted access. Extranet, controlled security measures for authorized users from different organizations.